64, 68, but the number of copy arrays. So for this problem, we are getting an original array, and we are also getting a bound. So the length of the original array going to equal to the length of the bound array. So what does that mean? So this means for the first number, it is 1. And we can also choose a number inside of the bounds. For each of the bounds, we can choose a number. So for example, if we can choose a 1 from the beginning, and then we're going to choose the next number, and the next number must be inside the bounds. And the next number must have the same pattern as the original array. Because what do I mean by the same pattern? It means the difference from 1 to 2, 2 minus 1 going to equal to 1. The difference is going to be 1. So this means for the next number we're going to choose 2, and similarly for the next we're going to choose 3 and 4. So this is just one case. As we can see, there's another case if we're going to start from 2, because from the bounds for the first number, what if we choose 2? So it's going to be 3, 4, and 5. So this is another case. So we're going to return a 2. So the idea to solve this problem is just using the brute force. So what do I mean by brute force is that we're going to prepare the first bound. Yeah. So for the first bound, how many numbers we can choose? We can choose 1 and 2. There are only 2 cases. And after that, it's going to become smaller and smaller. It's going to be something like this. So from the beginning, the bound is going to be bigger. And after that, even though the bounds becomes bigger, it doesn't matter, but the final result is going to become smaller and smaller until we find the answer. Yeah, let me just try to explain why we can use this kind of a pattern to solve the problem. Yeah. So from the beginning, inside the first example, we can choose 1 and 2. This is we're going to call it lower, and this is higher. So the lower is 1 and the higher is 2. Now we're going to continue to check. So for 2 and 3 for the next number. So if this is the lower and this is the higher, and the difference is going to become 1. So 1 plus 1, lower plus 1, it's gonna be 2, and the higher plus 2, it's gonna be 3. And then we're gonna use this 2 to compare the bounds. So the bounds is 2 to 3. This means everything is okay. Now we're going to continue to check the next. Next, 3 to 2, the difference is 1. It means 2 gonna plus 1 gonna become 3, 3 plus 1 gonna become 4. So 3 and 4, and the bounds is 3 and 4. This means we don't need to change. So it's gonna be 3 and 4. And after that, it's gonna be 4 and 5. So 3 plus 1 and 4, 5 and plus 1. This means the lower and higher range. So the bounds is also 5 and 4. This is lucky for us. So we just need to return the final result. It's gonna be 5 minus 4 plus 1. It's gonna be 2. Yeah, so what if the bound for the last one? Let me just use another example. For the last one, instead of 4 and 5, so the bound is going to become 4 and 4. So this means for the lower, we can choose 4. Yeah, basically we're going to choose this number. The maximum of 4 and 4 is going to be 4. And for the next number, it's going to be the minimum of this 4 and 5. So what is that? It's going to be 4. So if the bound is 4 and 4, so the final answer gonna be 1. It's gonna be 4 minus 4 plus 1. It's gonna be 1. Yeah. So this is just the brute force and mathematical idea to solve the problem. Yeah. What are we gonna do? We're gonna prepare a previous array. It's gonna be the bounds 0, and the length of the array gonna be n. It's gonna be the original array. So now we're gonna check the second number inside of the original array, or the second bound inside of the bound array. So for I in range 1 to n. First of all, let's just check the difference. So the difference is gonna be the inside of the original array. It's gonna be I minus original array of I minus 1. So we got the difference array. So what's gonna be the next possible result? So we're gonna use lower maybe and upper. So for the lower, it's gonna be the let's say, yeah, we're gonna prepare a range. So lower and upper, definitely it is dependent on the yeah, it is dependent on the previous range. Yeah, So for the lower, we're going to use a maximum, and for the upper, we're going to use the minimum. So for the lower, we're going to use the prep 0 because it is always lower. So prep 0 plus the div, but we need to control it inside of bounds. So it's going to be controlled with the bounds I with 0. And similarly, we just need to copy it to make the upper. So the upper is going to be prep 1 plus the div, and with the minimum of the bounds I with 1. We must understand the formula because I've already explained why we're going to use this kind of formula to solve the problem. It must be inside the bounds. Yeah. Now we're going to prepare the previous bounds. So the previous bounds are going to be lower and upper. So for the next one, we're going to continue to use the previous bounds, and the previous bounds are going to become smaller and smaller. So finally, we just use the previous bounds of 1 minus the previous bounds of 0 plus 1. This means if everything is okay, but what if everything is not okay? We need to return a 0. So yeah, this means the lower should always be less than or equal to the upper. But if the lower is the lower is more than upper, definitely it didn't work. So we're gonna use a max. It's gonna be max 0 to the final result. This means the final result is gonna be at least 0. Now let me just run it. As you can see, it works. Now let me just submit it to check if it can pass for all testing cases. As you can see, it passed for all testing cases, and it's pretty fast. I think that's all about it. Thanks for watching. See you next time.